Today, we're going to tackle the OSI model. Look, if you've ever found this thing confusing, you are not alone. It's usually taught in this super dense, technical way. So we're going to do things a little differently. We're going to break it down by telling a simple story.
Okay, so let's start with something you do, 100 times a day. You tap a link on your phone and poof, a web page just appears. But what's actually going on in between? What kind of journey does that simple request take?
All right, to really get this, let's set up a super simple scenario. Just imagine your phone, a web server, and a router are all hanging out on the same local Wi-Fi network. All your phone wants to do is grab a simple web page, index.html, from that server. So, our journey kicks off right where you'd expect, with the app you're actually using. This is layer 7, the application layer. I'm talking about the software you can actually see and touch, your web browser.
So when you go to that web page, your browser cooks up this message, an HTTP GET request. You can kind of think of it like a formal letter to the server. It's packed with stuff like headers that describe what you want, and maybe some cookies, which are just little breadcrumbs of data from the last time you visited. And once that text is ready to go, the application's part of the job, it's pretty much done.
Okay, so that big chunk of text gets passed down the chain to the next layer, layer 6, the presentation layer. This layer is basically a mix between a translator and a security guard for your data.
Now, in our simple example, we're just using plain old HTTP, so the data pretty much just sails right through. But if this were a secure connection, HTTPS, this is the layer that would do all the encryption, jumbling it all up so nobody snooping around can make any sense of it.
All right, next up is layer 5, the session layer. And its whole job is to manage the specific conversation between your phone and the server, making sure that the data from the web page you're loading doesn't get mixed up with, say, you're streaming music in another app.
So how does it do that? Well, it slaps a unique tag on the data, a Session ID. This is basically like giving the conversation its own name. So when the server gets a flood of data, it knows that this particular chunk belongs to, for example, session number 7.
Okay, now we're getting to a really important stage. Layer 4, the transport layer. This thing is like the shipping manager for a massive warehouse.
What it does is it takes our big chunk of data and chops it up into smaller, more manageable pieces called segments. And each little segment gets 2 really important labels. First, a port number. Think of it like a specific apartment number for the right app on the server, port 80 for web stuff. And second, a sequence number, so all the pieces can be put back together in the right order when they arrive.
Okay, so our message is all chopped up, and it knows which application to go to. But now we need to get it to the right computer. And that's the job of layer 3, the network layer. You can think of this as the internet's global postal service.
So it takes each one of those segments and wraps it up in something called a packet. And just like a real-life envelope, this packet gets stamped with 2 addresses, where it's going and where it came from, the destination and source IP addresses. This is how your data finds its way across the entire internet.
All right, we are getting so close to the actual hardware now. We're at layer 2, the data link layer, and this is all about the final local delivery. This is like the local mail carrier who has to find the exact apartment inside a huge building.
So at this layer, the packet gets another wrapper. This time it's called a frame. And this frame gets tagged with the MAC address of the destination device. You can think of a MAC address like a fingerprint for your device's network card. It's a unique serial number that's literally burned into the hardware. It never, ever changes.
Okay, so this is super important to get. The IP address from layer 3, that gets your data to the right network. You can think of it like the address of the hotel. But the MAC address from layer 2, that gets it to the specific individual device on that network. It's the exact room number in that hotel. See the difference? One's logical, the other's physical.
Wow. Okay, so we've gone from a simple text request all the way down to these frames of 1s and 0s. So what's the last step? Layer 1, the physical layer. How do these digital bits actually travel through the real world?
And this, right here, is where the real magic happens. It takes that long string of 1s and 0s and turns it into an actual physical signal. If you're plugged in with a cable, it's a pulse of electricity. But for our phone, it's a radio wave that gets sent out by the Wi-Fi antenna.
All right, so our message has made its way down all 7 layers. It's been converted into a radio wave, and now it gets broadcast.
But here's something about Wi-Fi that might just blow your mind. That radio signal doesn't just go on a straight line from your phone to the server. No, it's broadcast out in all directions, which means every single device on your Wi-Fi network, your laptop, your smart TV, your roommate's phone, every single one of them gets that signal.
So wait a minute. If every device gets the signal, how does only the right one actually process it? Well, the answer is the OSI model, but this time it's working in reverse.
The whole unpacking process is kind of like opening one of those Russian nesting dolls. So, at layer 2, every device's hardware looks at the MAC address on that incoming frame. Only the server, when it sees its own MAC address, says, hey, this one's for me, and accepts it. All the other devices just ignore it. From there, it just goes right back up the stack. Each layer strips off its own header, checks the info, and passes the good stuff up until, bam, the original GET request is delivered totally intact to the web server app.
So why does any of this even matter? Well, understanding this whole layered process is not just for, a test. The real genius here is that each layer only has to worry about the layers right above and below it. That means you could swap out your Wi-Fi for an Ethernet cable down at layer 1, and your web browser, way up at layer 7, wouldn't have a CLO. It just works. But it also has some massive real-world implications, especially when it comes to your security.
Okay, remember how we said every device in the network gets a copy of everyone else's data? Well, that is the fundamental reason you hear people warning you over and over again about using the public Wi-Fi at a coffee shop or the airport.
Because think about it, if that data wasn't scrambled back at the presentation layer, if you're on a plain old unencrypted HTTP site, then literally anyone on that same network can grab those broadcasted frames, piece your message back together, and read it just like it was plain text. So this question isn't just some hypothetical. Knowing how this whole journey works, from a simple tap on your screen all the way to a radio wave in the air, it should fundamentally change how you think about staying safe online.